Hello. Can you guys hear me?
Yeah.
Okay. Share my screen. You guys see my screen?
Yes.
So I'll just start in like 1-2 minutes. I'll just wait for. So meanwhile, maybe we can have a recap. Uh, so in the previous class, what we have discussed is the basics of probability, and we have discussed what is a joint event, what is a simple event, what is the probability, how do you find that, and we discussed general addition root p of a and b equal to p of a plus p of b minus p of a or b, right? Or you can say p of a or b equal to p of a plus p of b minus p of a and b, right? So general addition rule. Then one of the important concept from the perspective of machine learning that we have discussed is conditional probability. what what we have learned about conditional probability is conditional probability is there are two events where a and b, for example, and p of a by b represents that what is the probability of a given that b has already occurred, right? So you guys remember the car AC and CD player example, right? So that is conditional probability. Now these are the basic things that we have discussed. So today we'll discuss the extension of that. So we'll start discussing more about uh, we'll discuss more about the other parts. For example, what is the extension of conditional probability? How do you, what is Bayes theorem? All those things. Okay. So any questions so far before I start? So these are the things that we have discussed yesterday. So let me download this. So I hope you guys are following how we can connect the dots. For example, how probability is going to be used. We'll discuss all that. Okay. Okay, so let's start. So some more theoretical concepts, and then I'll explain Bayes theorem, and then maybe we can do a little bit of Bernoulli distribution, right? No, binomial distribution, not Bernoulli. Okay. Now, so statistical independence, right? So let's say if there are two events, so two events are independent if and only if P of A by B, given that what is the probability of A, given that B has occurred, is equal to P of A. So events A and B are independent when the probability of one event is not affected by the other event. Okay, can you guys give an example? So let's say there are let's say there is a probability of event A and there is B. They are called independent when the probability of one event is not affected by the other event. So can you guys give any example? Anything? I hope you guys can hear me.
Yes, odd and even numbers.
Yes, we are able to. Okay, odd and even. Can you formulate it properly? Odd and even number is 2, 3, 4, right? But
Yeah. And even are like 2, 3, 4. Odd is like 1, 2, 3, 5. Like occurrence of an odd number will never affect an occurrence of an even number.
occurrence of, okay, so that is mutually exclusive, right? So if one can occur, other cannot occur. So here it's asking about independent. So one of the example is, let's say the event A is, let's say if I roll a dice. Okay, so the event A is roll a dice and event B is flip a coin, right? So flip a coin. Now by rolling the dice in the beginning, right? So will it have any effect on flipping the coin?
No.
Right? Because they're independent. You rolling a dice and flipping a coin, always the probability of flipping a coin heads and tail is 1/2 and 1/2. It has no effect Like if you roll a dice 2 times, 3 times, 100 times, of course it doesn't have any effect on the flipping a coin, right? So that's what they're explaining here. So P of A by B, meaning probability of A, given that B has already occurred, is equal to P of A, which is probability of A. So then A and B are called independent. So what you guys are explaining is mutually exclusive. So the example was, let's say if you're having a child, so let's say if you are having a girl, then you cannot have a boy. Or let's say if you have a boy, generally you do not, don't have a girl at the same time in general scenarios, right? So that is the mutually exclusive. So this is independent. Any questions, like any confusion?
Oh, okay, can we relate like departure of a train versus sales of a ticket?
Departure, yeah,
A train, it won't be, it will be independent in its own.
right. So that's a good point. So both of them might look they are dependent, but of course the ticket price is fixed, and it doesn't matter if the train goes first or late. So like that, there are many examples. So what they are trying to explain is, so we'll see there is multiplication rule. So we have discussed addition rule, right? So we'll discuss multiplication rule. So there we'll use independence. Okay. Yeah, that is correct example. So they don't have any relationship. It won't affect. So I hope you guys remember the addition rule. So addition rule was something like this. So P of, let's say A and B equal to, so P of A plus P of B. I hope this is what we discussed towards the last, the mathematics taking statistics, all that example. So P of A or B. So this is your addition rule. Right? So this is called your addition rule. Now what we are discussing is multiplication rule. So multiplication rule is given by P of A and B is equal to P of A by B times P of B. Okay. Now if A and B are, so let's take this part. Now this, if what they're trying to explain is, so let's say if A and B are independent, meaning that the occurrence of B has no effect. Just now we have discussed that P of A by B will be equal to P of A. Okay. Now this particular formula will in turn become this one. So that's what they are trying to explain. So general conditional probability, you guys remember, right? So the conditional probability formula was given by P of A pipe B, which means that what is the probability of A? So given that B has already occurred. So this formula was given in the yesterday's class as P of A and B divided by P of B. Okay. Now what they're trying to do is they are just sending this here. Okay. So this is what is on the left hand side, and this multiplied with this is on the right hand side over here. So any confusion on this? So this is very simple. So the conditional probability they have written in a different way. Now what they're saying is, in this particular situation, if A and B are independent, we know that P of A by B will just become P of A. So this particular number or this particular probability will be replaced as P of A. So basically probability of A and B is equal to probability of A times probability of B when A and B are independent. So that's what you have to remember. Okay, so this is just theory. Generally you might get some MCQ, something like that. So we'll just solve a problem so that you guys will understand. So suppose a city council is composed of 5 Democrats. So let's say there are 5 Democrats, so 5D, and 4 Republicans, so 4 Republicans, and 3 independents. Okay. Now the question is, find the probability of randomly selecting a Democrat followed by an independent, right? So what are the total number? So total number is 12, right? So I've told that always start with the denominator, right? So what is the question? So question is probability of randomly selecting a Democrat. So which is probability of selecting a Democrat. So how do we start like with that? So how many Democrats are there? We should always start with the denominator, which is 12. And what is the total number of Democrats, which is 5. So this 5 by 12 is basically probability of T, which is basically probability of Democrat. Also they have told followed by an independence. The only difference is basically now this is already occurred. P of D is already occurred. and P of I by D, meaning that what is the probability of selecting an independent given that a Democrat is already occurred. So the only difference is the denominator will become 11 and the independents are basically equal to 3. So that's why you get 3 by 11 multiplied by 5 by 12. Any confusion on this? Any doubts, any confusion? I hope you guys are following today. I don't like this is less participation. Any questions, any confusion, you guys can ask me so that I can explain.
I have one question.
Okay.
How can you say that these events are independent?
So how can we say that these events are independent?
Yes, yes.
Now, what is the dependence that you see here? Is there
I
any?
mean, yeah, all are from same sample space, so they are independent, obviously.
No,
I think
it's not like that, right? So dependence is generally like, for example, how do I explain? So let's say if the so okay, so that's a good question. So let's say, let me clear this. Okay, so let's say if you forget about independence of the events. So how will you approach this particular problem? So let's say if you want to just forget about this part. Just forget about this part.
okay.
Okay, just forget about this. Just focus on this part. So as I've explained, first we will find the probability of selecting a Democrat. Okay. Now this part is clear, right? So 5 by 12.
Yes.
Okay. Now ignore this part. So what I'm asking is, let's say if they are dependent. So will there be any difference in the calculation? So let's forget about theory and let's say what is the probability of selecting an independent given that Democrat is already occurred, right? So how will you approach this? So this is the way you'll approach, right? So basically, again, what I'm doing is how many of them are remaining. So remaining is 12 minus 1 because one Democrat is already selected. And how many independents are there? Basically 3. Okay. Now, so what they're trying to explain is here, this is actually not independence. This is just a simple formula of conditional probability. So what they're trying to explain is P of I and B can also be written as P of I pipe T multiplied by P of T. Had it been independent events, so the formula will be P of I multiplied by P of T. We just now saw that if I and D are independent, so the answer is basically P of I multiplied by P of T. But in fact, given the fact that they are using P of I pipe D means that there is some dependence. It doesn't mean that they are independent events. You're right on that. That's what I'm trying to say. Okay, if they were independent events, so let's say P of I and P of D, if they are independent, the formula will become something like P of I multiplied by P of D, correct? Just now we saw. But here what they're explaining is it is not independent. They are of course dependent. So that is the reason they have I pipe D multiplied by P of D. Okay, so let's say this is, I'll explain. So let's say this is rolling a dice and it falls on 1 and flipping a coin and it falls on head. Right. So what is the probability? Probability is basically 1 by 6 multiplied by 1 by 2 because these two are independent events, right? So let's say when you roll a dice and when you flip a coin, what is the outcome that I'm looking? I am looking at an outcome where the dice will land on 1 and the coin flip will land on heads. So then I can write it as P of P of 1 multiplied by P of H. So which is basically equal to 1 by 6 multiplied by 1 by 2. So the answer is 1 by 12. So since this is the example of independence, so this is just a conditional probability formula. Is it clear now?
Yes, that makes sense now.
Okay. Any other questions? Okay, so if you're getting confused, take some time. You guys, I don't know how many guys have, just take some time, go back. Let's say if you can spend like half an hour. So you guys will try to understand like what is the formula. So like generally what happens is in weekdays, a lot of subject is taught so in one shot, so it's difficult to keep up. So yesterday only we discussed general addition, today we are discussing multiplication. So if you guys can get a chance, go back, like when the class is finished, go back through the material, or let's say if it's a video also, you can go back one more time. Okay, so that way you'll be like more familiar and more confident, like you won't get confused again and again. Okay, so in the previous class also we were able to break down the simple probability into joint probabilities. So here also we can break it down with the help of multiplication rules. So if you guys remember this, so this will come in Bayes theorem. So we'll explain, I'll explain like how is it used. Okay, so this marginal probability. Now let's get to the Bayes theorem. So as I've explained, so I'll explain one more time. So there is a random variable. Okay, so there is a normal probability, simple probability. If there are two events, then there is conditional probability, CP, and the extension of conditional probability is called Bayes theorem. Okay, now till here it's your basic probability and statistics. Now generally there is a formula or an algorithm called naive Bayes. Okay, so naive Bayes is a machine learning algorithm. So this is machine learning. So machine learning algorithm, so naive Bayes. So naive Bayes is completely dependent on Bayes theorem. So that is the reason we are discussing all these things. So there are two reasons. One is you can learn more about Bayes theorem, and one is generally people ask small questions in interviews related to probabilities. Okay, so some theory. So Bayes theorem is basically developed by Thomas Bayes in 18th century. So it's an extension of conditional probability. So I'll show you the formula. So this is how the formula looks like. So it might look like, what is this money like? There are a lot of things going on. So I'm going to explain in simple terms. Then you guys work out on one more problem. So you guys will get one idea. Now Bayes theorem is, in simple terms, what Bayes theorem is trying to explain is, so, so let's say BI means the ith event. Okay, so what I've explained, so the extension of conditional probability is Bayes theorem. Okay, now what I mean by extension is basically in conditional probability you have event A and B, right? Bayes theorem is anything more than 2 and 3. So let's say if you have events A, B, and C, something like that. Okay, or let's say you have 4 events A, B, C, and D. Right, so this is just an extension of this particular formula. Okay, as you can see, all of these are actually conditional probability. So this is conditional probability. So this is conditional probability. This is also conditional probability. So I'm going to make it simple for you guys, and then I'm going to explain. So let's say if I take K equal to 2. Okay, now how does the formula look like? So P of, let's say, so B pipe A, okay, equal to P of A pipe B I, okay, times P of P I. Okay, I'm just trying to simplify this for you guys so that this bigger sentence is more clear. So P of A pipe B1 multiplied by P of P1. Since K is 2, how many terms will I have in the denominator? How many? 2. Right, so since I have K, right, so K I have, for example, for explanation purposes, simplicity purpose, I'm just writing this for K equal to 2. So let's say BI, so let's say B1, okay, B1, so this is B1 and this is B1. Now what is happening here? So what it means is, so let's say if you know the conditional probability of A, given that B1 has occurred, okay, generally, okay, and you also know the probability of A given that B2 has occurred, and you also know the individual probability B1 and B2. Okay, so these are the probabilities that you already know. Okay, so what are the probabilities that you already know in Bayes theorem? The probabilities that you already know are P of B1, so probability of event B1, okay, probability of B2, okay,
Hello.
and probability of,
Hello.
yeah, someone asking a question.
Yeah. Actually, you have taken IS2, right? So in
Yeah.
case of that IS2, the upper one should be like A probability of A given the B is 2, right?
No, that is I, right? I'm taking k equal to 2, right? So I'm taking k equal to 2 and
Okay,
I equal to 1. K is below. So bk is,
okay,
okay. I
okay,
is on the top. Okay.
okay.
Okay. Any other questions?
Yeah, Mani, can you explain what is I and K here? I is what? K is what?
These are two events. So let's say B1 and B2 are events. Okay. And you have total three events. So let's say A, B1, and B2. Okay. So these are the three events. Now, if it is only two events, A and B, you can use conditional probability. But since you have three events, A, B1, and B2, we are using the extension of conditional probability, which is called Bayes theorem. Okay. Now, these are the events. We'll see an example.
So I is like 3, right? And K is 2.
I is
3 events.
yeah, three events, total three events. The three events are one is A, one is B1, and one is B2. Total of them are three. Okay. I is basically 2. Is there a confusion?
Yeah, I can be 1 or 2, anything, right?
Yeah, I can be 1 or 2. That is what this formula is actually trying to explain. Okay, you can replace B1 or B2. If it is B2, okay, if it is B2 here, so you will get B2 here, and you will get B2 here.
How we will decide it should be I should be 1 or I should be 2?
Okay, so let me directly go to the example.
Yeah, will that value be same now if I replace I as 1 or 2? It could be different, right?
Will the, sorry, what is that?
If I say if I use B1 or B2 in the formula, the resultant value will be different, right?
Right, of course.
Uh, okay. Then,
Let me explain an example so that you guys
yeah. And it need not be same always. I mean, I'm just
need not be same as a.
because let's say this P of B I given A, right? It's BI given A. Okay. It's
No,
not B. Okay.
let me explain an example.
Okay. Let's take.
So let's say Bayes theorem is a way of finding a probability when we know certain other probabilities. So the formula is P of A by B is equal to P of A times P of B pipe A divided by P of B. Okay. So this is actually conditional probability. So what it means is there are only two events. Okay. A and B. Okay.
One thing here. Yeah, on conditional probability, the formula was P of A given B is P of A and B divided by P of B, right? This changes a bit here.
Yeah. So what is the probability? P of A pipe B is given as P of
A and B divided by P of B, right? So that was the formula for conditional probability.
Right. So this is a conditional probability. What they are trying to explain is now can I write this P of A and B as, can I write this as P of A multiplied by P of B by A? Can I write this? B pipe A.
Not sure.
Okay.
As per the multiplication rule which we saw just now, right?
Correct. Let me start again. So what did we learn here? So let's say, so the multiplication rule, so what does it explain? So the multiplication rule explains P of A and B can be written as P of A pipe B times P of B, correct? At the same time, can I write it as P of A multiplied by P of B pipe A? Because P of B by A, I can expand this as P of B and A P of A and P of A will get cancelled. You'll get back P of A and B. B and
Okay.
okay. Now what they're trying to do is, I think this is the confusion. So what they're trying to do is just trying to extend this for a generic events, right? So let's say if there are more events. So let me finish this example so that you guys will understand, like in general, like how much you have to understand Bayes theorem. Like if it is too confusing, I'll explain like how much you have to understand. Okay. Now let's say this is the formula. Okay. So this can be rewritten as whatever I've explained. Okay. Now, what are the things that we already know which tells us how often A happens given that B happens, so which is given by P of A by B. Okay, so the question is, we are trying to figure out what is P of A given B. Okay, now this is what we are trying to figure out. Now, what do we know already? What are the things we already know? We know what is the probability of A, we know what is the probability of B, and we already know what is the probability of B given A. Okay, if I know these three things, which is probability of B given A, probability of A, probability of B, then I can find what is the probability of A given B, the ulta. So this is the ulta of this. You guys can relate here. I hope this makes a little bit more clearer. So what we are trying to do is, okay, if we have probability of A already known, if we have probability of B already known, and if you already know what is the probability of B given A, okay, if you know these three things, can I find, the question here is, can I find probability of A given B? So this is given by your Bayes theorem in the simplest form. Now what I've explained here is the complex form, like where you have so many events, B1, B2, B3, B4, B5, B6. But what we have here is only one event, which is P of A and B. Sorry, two events. Okay, so let me explain a little bit more about this example so that you guys can understand. So let's say P of fire means how often there is fire. Okay, so this part is clear. P of smoke means how often we see smoke. Okay, so I hope these two things are clear. Now let's define our conditional probabilities. The conditional probabilities are P of fire given smoke means how often there is fire when we can see a smoke. At the same time, can I also ask a question, which is P of smoke given fire means how often we can see smoke when there is fire. Okay. Now, so the formula kinds of tells us forwards, P of fire given smoke, when we know backwards, which is P of smoke given fire. So that is the confusing part. So what is the confusing part? So when you already know P of B given A, P of A, P of B, you're trying to figure out what is P of A given B. So this is what your Bayes theorem is generally used for. Okay, so if I explain more on this particular example, so let's see with actual numbers. So dangerous fires are rare. Okay, so let's say what is the probability that is given. So P of fire. So P of fire is given as, so P of fire is given as 1%. Okay, now but smoke is fairly common, 10%, due to barbecues. Okay, so barbecues, let's say you have a grill and then you have some food and then there is some smoke coming out, right? So that is what they are trying to give. Okay, now what is that? So that is 10%, which is given as P of smoke. So P of smoke. Okay, so P of smoke. Now, what is the other thing that is given? 90% of the dangerous fires make smoke. So that is clear, right? So whenever there is a fire, of course there will be smoke, right? So that is general, right? So that is given here. So P of smoke, P of smoke given fire. Now, what I'm interested in finding is we can discover the probability of dangerous fire when there is smoke. So that is what we are trying to figure out. So we are trying to figure out what is probability of fire given smoke, right? So if you forget this part, so what are the things you need to find these things? You need P of fire, you need P of smoke, and you need P of smoke given fire, right? So these are the three things we already know. Okay. So since if I substitute these substitute these things in the Bayes theorem formula, I get the percentage as 9%. So it is still worth checking out any smoke to be sure. Okay. So what we already know is whenever there is a fire, okay, whenever there is a fire, there will be smoke, right? So that is very clear to all of us, right? So 90% of the times. Okay. Now generally fires occur at, let's say, 1% chance, right? So generally fires occur at 1%. And generally there is a smoke, which is actually 10% because of the barbecues, something like that. Okay. Now what they're asking is, let's say if you are someone and there is a smoke, right? So let's say there is a smoke. What they're asking is, what is the probability of fire? What is the probability of fire given that you already see smoke, some smoke? So that is also possible, right? So generally, if you apply, if you think in normal terms also, generally if there is some smoke, people think, is there any fire associated with that? So that is what they're trying to figure out in this particular formula. Does it make a little bit more better, or is it still confusing? How many people understood this part?
Understood a bit.
Yeah, understood a bit. Okay, good answer, honest answer. Okay.
Understood.
Yeah, I got it.
So, can you explain third sentence, how to read again?
How to read?
Yes.
How to read?
Yeah, like in 90% of dangerous fire makes smoke.
90% of the dangerous fire makes smoke. Okay. Now, yeah, that's a good question. So this is simple. This is simple. Now, how do we read this part? So there is fire and there is smoke. Okay. Now, what they're trying to explain is 90% of the dangerous fires make smoke. Okay. So what is occurring first? First, it is occurring fire. Then it is making smoke. So you, in conditional probability, what I've explained is anything that is already occurred will come in the denominator. Okay. So let's say when I say P of A by B, which means B has already occurred. Okay. Now 90% of the dangerous fires make smoke. So making smoke is the secondary part. So let's say if you put fire, fire will come first and smoke will come later, right? So what is the first event that is already done?
Fire.
Fire.
Okay, I think I'm explaining in reverse actually. But so what I want you guys to take away from this particular example is, so generally Bayes' theorem is in this particular manner. So all you have to do is generally figure out what is the formula. So let's say what is that they are trying to figure out. So they are trying to figure out probability of dangerous fire when there is smoke. Okay, so fire and smoke. So let's say how I approach this particular problem. So I know that this particular probability of fire and smoke, all I have to do is there will be something reverse. So something reverse, which is basically probability of smoke given fire. Okay. And then I need two more things, which is basically probability of fire and then probability divided by probability of smoke. Okay. Now, if I understand this sentence properly, I can directly formulate this here and then I can directly substitute this values. If you are getting too confused with this, let's say what the way I would approach is, so what is the question they are asking? The question is probability of dangerous fire when there is smoke. Okay, so smoke is already occurred. So smoke is already occurred and they're asking what is the probability of fire. So this is unknown, right? So this is what we don't know. And I know that in Bayes' theorem, the ulta of that will be in the numerator. What is the ulta of that? Probability of smoke given fire, probability of fire multiplied by probability of smoke. So is this simpler to remember and understand?
Yeah, it is simpler, but I'm confused with 90%. How come smoke and fire on the numerator part?
How come
90%? We are not taking in the formula 1% into 90% divided by 10%.
Right.
So
this is yeah. So this is individual probability. So this is probability of fire. Okay. So this is probability of smoke. Okay. And what is the other thing that I need? What are the three things that I need? One is your individual probabilities and the remaining is your conditional probability. So I'm just trying to explain like simple way of remembering this. Okay. Now what are they asking? They are asking what is the probability of fire given smoke. So what else can it be? So this has to be probability of smoke given fire. So that is the only option that is remaining here. Right. So that way also you can remember so that it will be easier for you. Your question.
But in the third statement, they have already given, right? Probability of dangerous fire, which makes smoke, is already given as 90%, correct?
Right. Now the question is probability of dangerous fire when there is smoke, right? So what they are giving, so what they're asking is, so let's say you go to your backyard. Let's say that you go here. Let's say there is smoke. Okay. Now they are asking what is the probability of fire they are asking when there is smoke. Okay, what is already occurred? Smoke is already occurred, right? So that is what they are asking, right? So this is unknown. So this is unknown. So I think you guys are getting confused between these two sentences. Is that correct?
Yeah.
Yeah.
Okay, so let me explain this again one more time. Now, what does P of fire pipe smoke means? How often there is fire? How often there is fire? Okay, how often there is fire when we can see smoke. So is this sentence clear? So P of fire pipe smoke means, let's say what you see first, smoke, and they are asking what is the probability that there is some fire, right? So there is some less probability because industries generally release some smoke, right? So does it mean there is fire? Yes, there is some fire below, but that's generally, right? Now, what does probability of smoke given fire means? How often we can see smoke when there is fire. Okay, how often we can see smoke. Now, what is the first event that is occurring here? The first event that is occurring is this is the fire. Okay, and they are asking what is the probability there is smoke. What is occurred first? Fire has occurred, right? So because this is what is there in the denominator. Now, generally we know that whenever there is fire, smoke will definitely be there, right? So if I go by normal terms also, I know that 90% generally has to refer to this only, because 90% of the times whenever there is some fire, of course there will be smoke associated with that. Okay, now these are the things that I already know. Okay, so what they are asking is, if I already see smoke, can you tell me what is the probability that there is fire? So the probability comes to 9%, which also makes sense, may make sense, because not all the times whenever there is smoke does it mean there is a fire, right? But there is a huge probability, or there is a greater chance that whenever there is a fire, there will be a smoke. Does it make more clear now? So just read this particular sentence. So the formula kind of tells us forwards when we know backwards. Does it help or still confused? So what I'm explaining is, so let's say forget about smoke and fire. So let's say you know P of A pipe B. Okay, you already know this. What does it mean? Probability of A given that B has already occurred. Okay, you know this. What is the other thing you know? The other thing you know is probability of A. Okay, what is the other thing you know? What the probability of event B occurring. Now what I'm asking is, can you find this one? Can you find probability of B given A? So that is the simplest manner of explaining Bayes theorem. So what I'm explaining is, you already know the probability of A given B has occurred. What is the probability of A? What is the probability of A? So these three things you already know. My question to you is, whoever is confused, can you figure out, or can you tell me what is the probability of B given A has occurred? So these two are completely different. They are not equal. They are completely different. I think you guys are getting confused here. So P of A by B is not equal to P of B by A. P of A pipe B is not equal to P of B by A. So whoever is confused, so let's say if I ask a simple question, so let's say you know P of A by B, P of A, P of B, can you give me what is the probability of P of B given A? Can you guys answer this part? Like if you answer this means you understood Bayes theorem.
In this simplified way, we can definitely understand. But when it comes to question, the question is in a way that it confuses us. That's the problem.
Yeah, I understand that part. Now, my point is, if you guys understand this part, now if you guys, so how many people understand this part? If this part is not clear, then I have to explain again. So that is what I'm trying to
do. This part is understood.
So this part is everyone, right?
Part is clear.
This part is clear for everyone. Any questions anyone has on this part? Okay. So this part is clear. Now let's try to understand how to read a probability question. Okay, so that part is clear for everyone. So let me go back here. Okay. Now what is the question? So what is the question that they are asking? Probability of dangerous fire when there is smoke. So what is, don't even go to Bayes theorem. So how do you define this particular sentence in probability? Now, what is the event that is already occurred? Can anyone tell me that part? That's all.
Smoke.
Right. So
Smoke is already.
smoke has already occurred. And what I want is probability of fire.
Fire.
So this is unknown. So everyone agrees with this?
Yeah.
Right. So what is unknown? Probability of fire given smoke has already occurred. So this part is the unknown part, what we don't know, right? Now probability of fire is clear. Probability of smoke is clear. Correct?
Yeah.
Right? Now what I'm saying is the simplest way of remembering this is, Mani, I know that there are three things that are required. Now I know that probability of fire and smoke is unknown. I also, so the way I approach this is, if I'm getting too confused, I will break it down into simple terms. So what is unknown? Probability of fire given smoke, correct? Now what is known? Probability of fire is known, probability of smoke is known. Now what is remaining? What is remaining is probability of smoke given fire. And this is the part, these are the three things that I know, that I need to know to use Bayes' theorem to find this unknown. Does it make a little bit better now? Now let's say if I understand this part, what is remaining for this sentence? This sentence, let's say if it is very, very confusing to you, of course you will say, Mani, this is what this probability is, because I know that three things are needed. Two things I already know. This is unknown. The remaining thing has to be this one. Now does it make simpler?
Yeah, it may make simpler, but I think so everyone is confused because of the sentence formation. Because fire makes smoke. F and S.
Yeah, sentence formation. Yeah, I agree with you. The reason that you are getting confused is because I've read about Bayes' theorem. I've done, let's say, 2-3 problems. Then I'm able to figure out what is the probabilities, right? So what is the event that is already occurred? What is the event that is occurring next? Okay. Now, if you break this sentence down also, 90% of the dangerous fires make smoke. Okay. Now, what is already occurred? Dangerous fires, right? So that is what they're trying to explain. So fire is already occurred and 90% of them are making smoke. Does it make a little bit simpler now? So break this sentence down here. If you're getting too confused, 90% of the dangerous fires. So which means fire has already occurred. Makes smoke.
Yeah.
Right, so it will take time. I understand. This is the first time you guys are learning about Bayes' theorem and probability. So I will share this link with you guys. So spend some time. Try to go through this particular example. Now this formula for everyone looks like, what is all this? This is nothing but when you have probability of smoke, let's say trees, let's say water, all that. So what I'm explaining is, here you only have two events, probability of A and probability of B. And someone has already mentioned, right? So there are different ways of using this. So one is Bayes' theorem and one is your conditional probability. Here I do not know what is the probability of fire and smoke. If I know probability of fire and smoke, then I'll use the different formula for conditional probability. Now the good answer is, the good news is, you generally don't do any of this by hand. You generally use sklearn package, which already has naive Bayes, which will already calculate all of these probabilities for you. So you don't have to like write it one by one. But the bad news is, generally people ask Bayes' theorem in interviews. So what you have to explain, anyone who asks interview, let's say if I ask you interview, can you explain me Bayes' theorem? If you explain two things, then I'll be happy. One is, Bayes' theorem is extension of conditional probability. Let's say if I already know three things. One is probability of A, probability of B, and probability of B given A. Then with the help of Bayes' theorem, I can find probability of A given B, which is backwards. If you say these two things, then you will be good to go. Okay, so I'm just explaining you guys from the interview perspective also. Generally, they don't dig too much deep into this interview also. So there is one more problem here. So can you guys work on this? If you guys have any confusion, of course there will be confusion. So I want you guys to work on this particular problem on your own, so that you guys will be able to understand how to come up with the individual probabilities. So this is already in the slides. I will upload this. I want you guys, answer is also there. Try to understand how you can apply this particular Bayes' theorem. If you have any other questions, you guys can reach out to me. In the next class, I'll explain. Okay, so I want you guys to try it at your own. Like even if you make mistake, it's fine. Try to break it down. Try to read the problem properly once. Try to understand what is first, what is last. Then you will be able to understand Bayes theorem in a better manner. Okay, does it make sense? So this particular Bayes theorem, how many people understood, and what is a like? Is there any other confusion still?
No, understood.
Okay. Now I think the problem here is the way that they have written the English sentence. So the way is a little bit confusing. So I understand that part. Now, if I was in your situation, what I'm doing is I need to know only one thing. So which is unknown. What is the unknown? I just know that probability of fire given smoke. So I know that ulta will be given in the question. So ulta will be given here. Even if I don't understand this sentence properly or completely, I will write probability of smoke given fire is 90%. Okay, because these sentences are.
I have one question, Mani.
Yeah.
So I understood the concept when there are two variables, fire and smoke. Let's say we have third variable as well in the same problem.
Right.
Then how to approach it? Can you please explain that again? First formula.
Right. So if there are three things, okay, so that is given in this particular example. I want you guys to once spend some time, try to understand if you are able to understand this part. If you're not understanding this, I'll explain in the next class. So if I explain this, you guys will understand for now, but once there is a new problem, you will again get lost. Like you will be like, wait, what is what is what? So that's the reason I've explained this example now, which is simpler. And this one is just little bit tricky. There are three events, S, U, and D. Just three things. Here, there are two things, A and B, like fire and smoke. Okay. Now, what I want you guys to is try to read this sentence 1-2 times. Try to understand if you can come up with the sentences, like the probability of success, probability of unsuccess, probability of, let's say, probability of D. Okay. Now, what I want you guys to is once read this sentence, okay, try to apply this particular problem and try to see if you are able to understand these three slides. If you're not understanding, I'll of course explain in the next class. Is that fine?
Yeah.
Okay. So if you don't, so I've seen this in previous classes. If you don't apply or if you don't practice, there is no way you will feel confident about probability. I can write it. I can give it in writing. So many people say I didn't understand probability properly, because if you don't practice it again and again, then there is very less chance that you will get confidence in probability. So my request to all of you is keep practicing. If you get time, let's say weekends also, just small questions like some of the questions, if you can practice, then you will be confident, like whenever a question is given. Okay, so let's try and see if we are able to solve some of the questions based on the concept that we have discussed so far. So if you toss a dice, I think, so what's the probability that you roll a 3 or less? So I don't want anyone to jump on the answer. Try to take 1 minute and try to think through it and answer. What is the option? Is it A, B, C, D, E? The question is, if you toss a dice, I think it's not toss, it's if you roll a dice, what's the probability that you roll a 3 or less?
One by two.
1 by 2.
1 by 2. Yes.
1 by
3.
2.
Okay, I hear 1 by 2. Okay, let's check if the answer is correct. Yeah, so the answer is correct. So the probability is basically 3 by 6, which is equal to 1 by 2. Okay, I hope everyone is clear on this part. So this type of questions you have to definitely answer without any mistake.
I didn't understood this part.
So can you solve it for me, Mahesh? So let's say, can you explain me?
Understood. I didn't understand.
No, what part you didn't understand?
How come 1 by 2?
I know that part. Like, what part in the question you didn't understand? Like, is the question you didn't understand, or is it the answer? Right. So let's say if I've given you this problem in interviews, how will you approach this? So what I've explained, probability is basically equal to, first you have to come up with your sample space. What is on the top, Mahesh?
Sample space is 6, right?
Sample space is 6. Okay. Now what is on the top? Like, what is the definition?
3.
Okay, 3. What is the answer?
1 by 2.
Is it clear now?
Yeah.
We solved it, right? So basically the definition is favorable outcomes divided by sample space. Right? Any other doubt? Anyone has any confusion on this? So this is a very simple problem. So any doubt, any question on this? Anyone has any doubt before I go to the next one?
No, clear.
Here, there will be a, I want to recall that at least they will tell, and one more is at most. That will be impact, right? Here it will be at most 3 or at least 3, like that.
Yeah.
Instead of or less.
Yeah, correct. That's a good point. So they generally use either 3 or less, or at most 3, or let's say at least. Yeah, so that is a different way of just trying to confuse you.
That the less part made me confused.
Right. So 3 or less means 1, 2, 3. Okay. If you are getting confused, read the question 1, 2 times. Always come up. Then you will come up with the numerator. Okay, so let me ask you one more question. 2 dice are rolled and the sum of the face values is 6. Take your time, don't jump to answers. What is the probability that at least one of the dice came up 3? 2 dice are rolled, sum of the face values is 6. What is the probability that at least one of the dice came up to 3? You always start with
1 by 2.
Sorry, what? 1 by
2.
Okay. Let's see. Let's wait for others' answer. Always start with the denominator, guys. Do not jump to the numerator. We'll make mistake.
2 dice are rolled means like 12, right? Sample size.
Mm-hmm. And what is your favorable outcomes?
3. What is the probability that at least one of the dice come up with 6?
Okay, so 2 dice are rolled and sum of the face values is 6. Okay. Now, what is the sample space here? Can anyone tell me what is the sample space?
12.
Yeah, like, can you also tell what are the values? Like 12, I understand, but what are the values?
1 comma
1 comma
5, 2 comma 4,
3 comma
3 comma 3.
And should I consider 5 comma 1 as separate, or 4 comma 2, 5 comma 1? Yeah, it is.
Okay, so how many are these? Like 1, 2, 3, 4, 5. And what is the probability that at least one of the dice came up to 3?
1 by 5.
1 by 5. Okay.
At least one of the probability.
So whoever told 12, why did you tell 12? Sample space?
I told the total sample space.
No, that is not what they're asking, right? So they're asking 2 dice are rolled. If they stop there, then yes. But they're asking 2 dice are rolled and the sum of face values is 6. Right? So this is the first sentence you have to. What is the probability that at least one of the dice came up to a 3? So I feel that you guys need to practice actually, or else you will make mistakes all the time here.
Yeah.
Right? Without practice, this is a very simple question in my opinion, but you guys have to practice. Right? So without practice, then it will be very difficult.
For practice, any site you're referring for questions?
Yeah, if I find, I think I have some website I'll share with you guys. But even these questions, if you can just practice once the slides are uploaded. Now, what I see problem is people are directly jumping. Like I always stress that sample space is important. That is where everyone is making.
Yeah, you can be policeman. I'll tell you a story of you being policeman. Okay?
Right. So,
can we have some more problems, or should we search in Google?
Yeah, I'll share it with you guys. URL. where there are some probability problems that you guys can. Okay. But before practicing, also you have to once revise like what is probability of A, probability of B, probability of A given B, what is probability of B given A, right? So generally they don't directly give you that; they give you English sentence. Like they say that probability of fire given there is 90% chance that there is fire when smoke has already occurred, something like that. So you need to understand how you can rewrite that and probability. Okay. Well, I'll share a URL where I think there will be some problems, or maybe if I already have some problems collected, I'll share that part also, so that you guys can practice on that. Okay. Now, what we have discussed till now in probability is basics of probability, addition rule, multiplication rule, conditional probability, base theorem. So these are the main important concepts in the basic probability, right? Now, there are some more concepts that you have to understand. So that is your probability distribution function. So these concepts will be used in your coming statistics class. Okay. So did you guys discuss this part? Did your instructor explain this part?
No, we didn't cover the probability.
No.
Okay. Okay, so let me cover this.
Distributions of probability were not covered.
Okay. Now, the first one that I'm going to cover is basically called the binomial probability distribution. So this is distribution. This is not a single probability anymore. Okay? This is a distribution. So what I mean by that is binomial probability distribution. A fixed number of observations, trials. Example, when you flip a coin 15 times, or there are 20 patients, or 1,000 people surveyed. Okay. Now, the key characteristics of binomial probability is, so let's say if you take an example of head and tail, when you flip a coin, right? When you flip it once, it's 50% and 50%. There is no confusion. But when you flip it 10 times or 20 times, right? So it's a probability distribution, right? So you're not flipping it one time, you're flipping it more than one time. So that's why you have a probability distribution. Okay. So what is the main outcome? The outcome is binary, meaning either it's head or tail. So there is no third option, right? So either it's head or tail. Binary means either 0 or 1, or let's say female or male, or dead or alive. Right? So all of these are binomial probability distribution. Okay. Now, the general convention is called success and failure. So let's say if head is what you are looking for, so probability of head is given as success and probability of tail is given as failure. And the probability of success is given by P, and the probability of failure is given by 1 minus P. So can anyone tell me why is this 1 minus P?
Because sum of probabilities.
Probability cannot exceed 1.
Right. So the sum of probability is always 1, right? So if you guys remember the dice example, 1 by 6 plus 1 by 6 plus 1 by 6 equal to 1. So similarly, probability of tail is equal to 1 minus 1 by 2, which is probability of head, which is also equal to 1 by 2. Right? So in general, you don't have to remember two things. You just have to remember one thing and you subtract 1 minus. So because there are only two outcomes, you generally do P, and P is basically called the probability of success. 1 minus P is generally called probability of failure. Okay. So constant probability for each observation. Okay, so let me make it smaller. I think the probability of getting a tail is same at the each time. Okay, so let's say when you flip a coin, the individual probability of getting a tail is always 1 by 2 all the time, right? So let me give you an example so that you guys will understand. Take the example of 5 coin tosses. What's the probability that you flip exactly 3 heads in 5 coin tosses? So can you guys just understand this particular problem before even trying to solve it? Like, can anyone explain or try to understand like what are they trying? Can anyone tell me like what is given?
Here 5-time trial is going on, tossing a coin. Of those 5 tosses, 3 are expected to be head.
Okay.
End result, which means 2 will result in tail.
Right, because there are only 2 events, because head and tail, there is no other option. Right? So that is a good explanation, right? So generally, if you understand this particular problem and try to break it down in those terms, it will be very easy for you to solve any problem. If you are having some challenge or getting confused, then you need to a little bit practice more. Okay. So let's see this particular problem. So let's see if we can solve this. So one way to get exactly 3 heads is head, 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 tail, tail. Okay. Is there any other way? I can get 3.
Yes.
tail, head, 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 tail, tail.
Right. If you
You,
Tail,
whatever.
tail, and head, all that. T, H, H, S, T.
this is one way. This is also one more way. So like that, there will be many things, right? So there will be right? So I understanding, right? So generally, what we do, we figure out like what are the total number of sample space. So can anyone tell me what is the sample space here? How many of these
15.
present? How much?
15 is sample space.
Sorry, 15.
25.
Why 25? How did you come up with that number?
Kind of permutation.
Yeah, you're right, but what are the options? So there are two options in the first slot, head and tail. Two options in the second slot, head and tail. Two options in the third slot. Two options in the fourth slot. Two options in the fifth slot. So which is 32. Right? So there are two options. Either it could be head or either it could be tail. Again, there are two options, which is either it could be head or either it could be tail. The third one also again head or tail. Right? So the total number of options that you can have is 32. Right? Now keep in mind, this is also one of the possible. Correct? This is also one of the possible outcome. But what we are interested in this one because it has 3 heads. We are interested in this one because it has 3 heads. We are interested in this one. Right? So if you club all of these, total of them will be 32. Right? But what we are looking for is favorable like this.
Your voice is getting faded, man. It's very tough.
Yeah, there is someone is. Remember to mute yourself. Okay, can you hear me now better?
Yeah.
So the point that I'm trying to make here is out of total 32 options, right? Out of total 32 options, the question says that what are the favorable outcomes where there are exactly 3 heads, right? So I'm just looking for the ones where there are head like this one. This is not a favorable one. This is not a favorable one. So like that, there will be some number. So what is that I'm looking for is that particular problem. Okay. Now there is a simpler way of solving this particular question. Okay. The question is basically, let me explain answer. So the answer is basically 5C3, okay, 5 combination 3. Okay. This is just a formula. So the formula that I'm looking for is when I flip a coin 5 times, okay, what I'm looking for is exactly 3 heads, and 2 tails. So 2 tails is obvious because 5 heads, then 3 heads, then remaining will be 2 tails. So probability of 3 heads and 2 tails. The formula is given by 5C3. So 5 is the total number, 3 is the number of heads that you're looking for. So 5C3 multiplied by probability of success, which is probability of head power 3. I think, can you guys mute yourself? Who is not having a question or not? See a lot of noise. Yeah, if you have any question, just unmute and then again you guys can mute. Okay, so what I'm trying to explain here is, so total number is basically 5. Among those, 3 of them I want head, 2 of them I want tails, right? So the formula is given as 5C3, okay, multiplied by probability of head power, or basically probability of success, okay, probability of success power 3, because I want 3 heads, multiplied by probability of failure, which is probability of tails, which is 5 minus 3, which is equal to 2. Okay. Now, can anyone tell me like how to find this particular combination 5C3? Like
Just go reverse. 5, 4, 3, 2, 1, 3, 2, 1. Reverse.
okay.
Divided.
Okay. Now
It's 5 factorial by 5 and 3 factorial into 3 factorial.
So I think few people.
Combine.
Okay. So I'll explain in simple terms. So 5 factorial just means it's nothing but 5 times, 4 times, 3 times. I'm just multiplying here 2 times 1. Okay. Whoever doesn't know this, so 3 factorial is nothing but 3 times, 2 times. Formula of the expansion of this particular formula is given by 5C3 means how many ways I can arrange this 3 heads in 5 slots. Okay. So the formula is given by 5 factorial. Whenever I write 5C3, you can expand this in this manner. 3 factorial, okay, multiplied by 5 minus 3 factorial. Okay, so with this information, can you guys tell me what is the value of 5C3? What is the value of this one? Can you guys tell me?
10.
Okay, only one answer. What about others? Any other answers?
1.
No, it's 10.
10.
10. 10.
10.
Okay. Now 5 factorial, you can write it as 5 times 4 times 3 factorial. Okay. Divided by 3 factorial multiplied by 2 factorial. Okay. So this 3 factorial and 3 factorial will cancel. 2 factorial is nothing but the value 2. 2 divided by 2. The answer is 10. Now, what do you understand from this 10? So 10 means nothing but there are 10 ways of arranging heads, 3 heads and 2 tails. You guys can see here, right? So there are 10 ways of arranging head, 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 tail, 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 head, head, head. So I hope you guys are connecting the dots. So the probability is nothing but 10 times multiplied by 1 by 3 power 3 multiplied by 1 by 3 power 2. So the answer is 10 divided by 32. Okay, is this point clear? So what we have tried. Yeah, any questions?
Just a small, I lost the frequency. Can you go back to previous slide?
This one?
Yeah, you had, okay. The 5 factorial divided by 3 factorial into 5 minus 3 factorial, right? So 5 factorial should go back up to 2 into 1.
5 factorial should go back up to?
How would you write 5 factorial? 5, 4, 3, 2, 1, right?
So you can write 5 factorial as 5, 4, 3, 2, 1.
Divided by, what do you have? 3 factorial.
2, 1.
3, 2, 1.
Right,
Again, we have 5 difference 3 factorial, which is 2 factorial. Again. 2 times 1.
Try this and tell me what is the answer.
Achha, sorry. Okay, man.
So this is cancelling. Right?
Yeah. Okay.
The answer is, yeah, so 10 divided by 30. Okay. So what it means is there is 30% chance that when you flip a coin 5 times, there is 31.25% chance that there will be exactly 3 heads. Okay. So that is how you basically find binomial probability distribution. Now, why is this a binomial probability distribution? Because there are only 2 outcomes, which is head and tail, right? Binary outcome, 0 or 1 or head and tail, right? At the same time, now what is the n value here? N value is basically 5. Okay, what is the probability of success? You are interested in heads, which is 3. And what is the probability of failure, which is tails, which is 5 minus 3, which is 2. Okay, so this is a very simple formula. You guys can just try to understand this part. So the key characteristics is this one. So you have to remember. So whenever your probability distribution is called, when is it called binomial probability distribution? Whenever you have a binary outcome, okay, head or tail, and the probability of tail in each attempt is equal, probability of head in each attempt is equal. Probability of success, if the probability is P, then the probability of failure is basically 1 minus P. Okay, so when you repeat this experiment n times, which is 5 times, 4 times, or 3 times, so the answer is you can follow binomial probability distribution. Okay, so let me ask you this question. Can you guys take some time and do it and then tell me the answer? So let's say if I flip a coin 4 times. Okay, so what is the probability that I get exactly 2 heads? Okay, can you guys try this particular example? Take some time, don't jump to answers. Even if others are telling answer, take your time, try to solve it on your own. So the question is, when I flip a coin 4 times, what is the probability that there are exactly 2 heads? I hope the question is clear for everyone.
Can you show the formula once?
Formula, okay. This is the formula.
0.25.
0.25, okay. I don't think it's 0.25. Let's see, let's wait for other answers. Just do it once, guys, so that you guys will get a practice and some confidence. So generally, I see that people generally don't practice. If you don't practice, then it is very, very difficult, because practice you will get more confidence and you'll be like very familiar with the formulas, all those things. Any other answer, guys?
0.37.
0.375 or 0.37?
0.375.
Someone told 0.25. What is the mistake there? Whoever has told 0.275 or 25, can you just check your mistake? Checking. Can you try it one more time so that you know what is the mistake? So I hear one answer, which is 0.375. Are there any other answers? Three by 8. Okay. 1, 2, 3. 6 by 16. Okay. 5 people have told. What about others? There are 35 people, I think. So there's a probability of getting answer is 5 by 35. Okay, so Neeraj, Abhishek, Sandeep, Ashwin, Kshitij, Yashpal. I think one more person has told. Are you just copying the answer? Are you just... Okay, so the answer is 0.375, 3 by 8, or let's say 6 by 16. Okay, so you can just substitute in this particular formula. So 4C2 and then multiplied by 1 by 2 whole power 2, 1 by 2 square, and 1 by 2 square again. So the answer will come up to 0.375. Okay, so like this, if you keep practicing, it will become more and more easier for you guys. Okay, so that is the basics of conditional probability and basics of binomial probability distribution. So let's see if I have some more. I'll just download one more. So till this point, I hope you guys have got some idea on like how probability questions will be framed, what type of questions you can expect, right? So any other questions or doubts before I move to the next topic? I'll just start with the simple topic. Let me see. Let me download. Any questions, guys? Any questions, any doubt, any clarifications before I start the next topic? Okay, so I hope there are no questions. So if you have any questions, just let me know, or else I'll start with the next topic. Okay, so I hope there are no questions. Sorry.
Mani, I have one doubt. What is the difference between Bernoulli's distribution and binomial distribution? Both are basically binomial events only there.
No, I think Bernoulli is a little bit different. So yeah, that's a good question. So in class, we generally discuss the basic ones. So there are so many distributions out there. So for example, if you guys want, maybe I can take some difference and explain what is the difference between Bernoulli and binomial. But generally what happens is the only difference that you will see is the way the problem or the probability is framed. For example, what I mean by that is, in binomial distribution, what is the key characteristics? What is the important thing that you have to remember for any distribution to say it is a binomial distribution? Right. So the answer is basically head and tail. Right. So success and failure. There is only binary outcome. Okay. If you dig more into Bernoulli or Poisson, or there are so many gamma, so many things are there. So what differs is the way you first establish your probability distribution. Now, let me check if I have Bernoulli in my slides. Yeah, I don't think Bernoulli is there. Poisson is there. Okay, anyhow, so let me just explain this complete binomial first. Then we can discuss more on the Poisson, and then if you still want, we can discuss about Bernoulli. Okay. Now, what I'm trying to explain is the only thing that differs is the way you understand the problem. Now, whenever I say binomial distribution, in the back of your head, you guys have to understand there is a binary outcome in the probability, which is head and tail, or dead or alive, or male or female, or let's say positive, negative, or something like that. So these are all binomial distributions. Okay. So we'll see in the coming classes, in the next class maybe, what is a Poisson distribution. If you guys want, I'll explain more on Bernoulli distribution also. Okay. Now, yeah, so if I go back to this particular slide, right, if I go back here, and if I compute the probabilities for all of these, right, so what it means. Now, can you guys tell me, is there any connection with this, with something that you guys have already learned? Like something, does anything come in your mind when you look at this image?
Normal distribution.
Right. So all the probability distributions, when you do it or when you try to plot it, right? So what it means is the probability of flipping a coin, which is basically 5 coin tosses, and there are no heads. 0 means there are no heads. So the probability is equal to 1 divided by 32. Is it 1 divided by 32? So what I'm trying to explain is probability of when you flip a coin 5 times, what is the probability that there are no heads, right? So what are the options in that? So the only option that you have here is tail, 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 and tail. In every other combination out of those 32 combinations, you have 32 combinations, right? In every other combination, there will be at least one head. Do you guys agree with that? Now, what I'm explaining is this particular
Yes.
This particular bar I'm explaining. So this particular bar value is 1 divided by 32. Okay.
Yes.
Right. Similarly, can you tell me what is the value of this?
Same, 1 divided by 32.
All are H, no T.
Right, 1 divided by 32. What it means is when you flip a coin 5 times, what is the probability that all of them are heads? 5 of them are heads. The probability is only 1 divided by 32. So what I'm trying to explain is, so there is normal distribution always following you like a ghost in statistics, right? So when you do it for certain number of times, when you plot it, right? So what are the possible outcomes here? There can be 0 heads, there can be 1 head, there can be 2 heads, there can be 3 heads, there can be 4 heads or 5 heads. So when you plot this in this particular manner, so where P of X is on the y-axis and on the x-axis you have the combinations or the number of heads you can get, then this particular distribution is generally normal distribution.
So all these particular distributions generally connect back to your normal distribution. Okay, so normal distribution is symmetric from the central to the left and then to the right. So these are the key characteristics of normal distribution. So that is the observation you guys have to understand here. Okay, let's say if I tell you this particular probability value is let's see how much, I think 6 divided by 32. Let's say if I tell you this, and if I ask you what is the value of this, can you tell me? Without doing formula and all that, just from the graph. As you guys have explained this, for the value of here is 1 by 32. Since normal distribution and symmetric, this is also 1 by 32, the probability value. If the value of this is 6 by 32, then the probability of this will also be 6 by 32. Okay. Now what is remaining? 1 plus 6, 7, 14, right? So what is remaining? 14. Then how much is remaining from 32? 14, 22. So let's say this is 11 by 32. So I think this is 10 by 32. Just now we saw 10 by 32. This is 10 by 32. Okay, so this is 7 by 32, not 6. So what I'm trying to explain is, if you are confusing with these values, it's fine. What I'm explaining is the probability of exactly getting no heads will generally be also equal to probability of getting all heads, right? So since this is a normal distribution or a symmetric curve like this. Okay, so that is the connection that you can draw between binomial probability distribution and normal distribution. So what it means is, internally or in itself, binomial distribution also slowly or closely follows normal distribution. Okay, now this we have already discussed. So NCX, I'm just explaining the formula one more time. P of X is basically probability of success, and X is the number of times you want that, and 1 minus P, which is the probability of failure, and N minus X is the total number of and minus number of successes. Okay, now anywhere this is called a binomial probability whenever you have the binary outcome, which is 1 or 0, or yes or no, or success or failure. Right? So these are all binomial probability distributions. Okay, now can you guys just solve this particular problem? If I toss a coin, you can use your phone or calculator. If you toss a coin 20 times, what's the probability of getting exactly 10 heads? I know answer is there, but can you just try it for yourself one more time? So these kind of questions you should not make any mistake, right? So these are just formula based, then you can just substitute and then you can get the answer. So the answer is 20C10 times 0.5, which is 1 by 2 whole power 10 multiplied by 1 by 2 whole power 10 again. So the answer comes up to 0.16. Can anyone confirm this? 1-2 persons. If you guys can confirm, I can move to the next slide.
One doubt, is it 20C10 or is it 10C20?
Sorry, 10, 20?
I mean, we are doing combination for 10 heads in 20.
Correct. So 20 will come. So whatever bigger number will come on the top. So this is illegal, by the way. I don't think this value works. Because if you find the 10C 10 factorial,
that's a fraction, yes.
Minus 10 you'll come. That is wrong. Don't get confused. So the answer is 220C10, 20 factorial on the top divided by 10 factorial times 10 factorial. Okay, so if you are taking some time, it's okay. Answer should be 0.176. Okay. So if I toss a coin 20 times, what's the probability of getting 2 or fewer heads? So can you guys don't need to solve this problem, but can you guys approach this? If I toss a coin 20 times, what's the probability of getting 2 or fewer heads? So which is basically 0 heads, 1 heads, or 2 heads. So since they are asking for 2 or fewer, you will basically add the individual probabilities. So is this question clear for everyone?
Yes.
Similar to your ER example, like at most 10 people, at least 10 people, all that. Okay. The question says, if I toss a coin 20 times, what's the probability of getting 2 or fewer heads? So basically you can get 0 heads, you can get 1 head, or you can get 2 heads. So you just have to substitute the formula, get the probabilities and add them. So that is the final answer. Okay. Now all probability distributions are characterized by an expected value and a variance. Okay. Now this might be a little bit tricky. So let me explain it. So let's say if I have these numbers, so 1, 2, and 3, right? So what is the average of these numbers? What is the average of these numbers?
2, 3.
2.
2.
Right? 2 is the average. So basically 1 plus 2 plus 3 divided by 3, which is actually 2. Now, since this is a probability distribution, the mean value, so whenever there are numbers, right? So you just clearly did money 1 plus 2 plus 3 divided by total number 3. Expected value means this is the mean of the probability distribution. So whenever you come across the word called expected value means that it is the mean or the mean value of the average value of the binomial distribution. Whenever you say the expected value of the capital X, which follows binomial distribution, which means that the mean value, right? So the mean value of this particular probability distribution function, which is binomial, is denoted by E of X, which stands for expected value of X. So these are just general formulas. So you guys can remember that. There will be some MCQs on this particular concept. So is it clear like what expected value means in case of probability distribution functions? Right, so just like whenever I give values, which is 1, 2, 3, when I ask you to find the mean, when you did 1 plus 2 plus 3 divided by 3, so that is your mean or the average value. Similarly, the mean value of any probability distribution is called expected value. Okay. Now, in this case, we are discussing about binomial distribution. So the formula of expected value is basically n times p. So let's say n is basically 20 times if you flip a coin. P is basically probability of success, which is equal to 1 by 2. So the answer is 10. Okay. Now similarly, if I ask you what is the mean and I ask you the variance, so you guys can figure out the variance. At the same time, you guys can also figure out the standard deviation. I think these are overlapping here. So the answer is basically n times. So the variance is basically n times p times 1 minus p, and the square root of variance is called your standard deviation. As I mentioned in the first class, so these three words will keep on coming again and again. So it's very important to you guys understand what are the formulas. So the square root of variance is given as standard deviation. So in this case, so this is the variance, and the square root of same thing, which is basically n times p times 1 minus p, is called your standard deviation of binomial probability distribution. Okay, are these three things clear? How to find the expectation, how to find variance, how to find the standard deviation of a binomial probability distribution.
Yeah, in terms of formula it is clear, but in terms of wording, whenever we'll be reading, if variance come up, that can you give in the wording for variance alone? Standard deviation will understand.
Okay. So let's see if there is an example. Actually, someone else was also asking some question.
Yeah, I want to understand like that expected value you have given as n into p, and also you are saying that it is equivalent to mean. So always if I calculate the mean as an average is always equal to n into p.
Yeah. So I
don't get that one.
Yeah. 1 second. I don't think I have slides for that. Let me do one thing. So let me actually pick that up in the next class and explain in a simple manner what is the expected value and what is the variance and what is the standard deviation. Just looking if there are any slides. I think they are all problems. 1 second. Yeah, these are all, there's no definition of expected value. So I'll explain in the next class. Don't worry, guys. So these are all problems that are there, which are just formula substitution, but I'll explain like what does expectation generally mean, or what does variance mean, or what does standard deviation mean in case of binomial probability distribution. In the next class, I'll explain, don't worry. Okay. Now, I think, so let's try some practice problems. So let's try if we can solve these particular problems with the help of formula. So you are performing a cohort study. If the probability of developing disease in the exposed group is 0.5 for the study duration, then if you randomly sample 500 exposed people, how many do you expect to develop the disease given the margin of error is plus or minus 1 standard deviation for your estimate? What's the probability that at most 10 exposed people develop the disease? Okay, so let's see if we can solve this particular problem. Okay, now what is given in the problem? So given in the problem, so is this a binomial distribution or not? If you are performing a cohort study, if the probability of developing disease in the exposed group is 0.5 for the study duration, then if you randomly sample 500 exposed people, now is it a binary outcome in case of disease? Can you guys tell me if the answer is yes or no?
Yes, binary.
Right? Either you will have the disease or either you will not have the disease. There is no like you will have half disease and doesn't make sense, right? That is what they are trying to explain. So they didn't directly give you this is a binomial probability distribution, but they're explaining you in different terms that either the person can develop a disease or he cannot develop a disease. Okay, so that point is clear. So what is the first thing that we have established? So this is a binomial probability distribution. Okay, so what is the total number of value, which is n equal to 500? So sample of 500 is given. Now what is the probability of success here?
Point 0.05.
Yeah.
The probability of success is 0.05. What is the probability of failure?
1 minus 0.05.
Which is basically 0.95.
Okay.
Just by reading this, first you thought like, wait, what is all this? But slowly we are able to figure out all the answers. Right? So basically what we have got till now, this is basically a binomial probability distribution. N equal to 500, probability of success is 0.05, probability of failure is basically 0.95. Okay, let's they're all related to expected values. So let me skip this for now. Let me explain maybe I think one second. I think these are all related to expected values. Yeah, all of these are related to binomial and then expected value. So let me do one thing actually. So let me actually explain you guys in the tomorrow's class what is the expected value, what is the variance, what is the standard deviation, how do you interpret them. Then we will be able. Then you guys will be able to understand these slides in a better manner, right? So I think I'll close the class today here. I think there are 20 minutes. I think today is a little bit shorter class. So tomorrow I'll start from the expected value, variance, and standard deviation, and then we'll try to cover these slides. So there is a Poisson distribution and there is. Is it fine, guys? So tomorrow I don't have slides actually. I have to maybe prepare them. Expected value, variance, and standard deviation. Tomorrow we'll pick up there and then maybe we'll solve some of the problems. Okay. So till this point, any questions, any doubts that you guys have? Any doubts that we have discussed till now in binomial distribution, or let's say conditional probability, or I think the.
I have one doubt.
Yeah.
Can you please explain the distribution table, distribution chart for the problem that you show?
Distribution chart.
I mean, not the chart, but the graph. Yeah.
This one?
This one. Yes.
So, okay. Okay, so what they're trying to explain is on this, what they're trying to interpret is, so in the previous example, the question was when you flip a coin 5 times, okay, when you flip a coin 5 times, the question that they are asking was, what is the probability that exactly you will see 3 heads, right? So this is a problem that we have discussed in the previous slide, correct? Now that 3 slides is that 3 heads is basically this particular value. So what is the value that we got there? The value was 31.25%. So what I'm explaining here is this particular bar here, which means this is 3. So the number of heads on on the x-axis, what I have is the probability of exact number of heads. Now this one we already solved, right? So the answer is 31.25%. Now, what does this mean? This means when you flip a coin 5 times, what is the probability that you see exactly 0 heads? Exactly 0 heads. Now, can you tell me like what is the probability that there are exactly 0 heads when you flip a coin 5 times?
That's 1 by 32.
1 by 32 because there is only one case where there is 0 heads, which is basically, so you have like this 32 total. The last one is where you have 0 heads, correct? So T. So what this particular bar here represents is exactly 0 heads when you flip a coin 5 times. So the probability is 1 by 32. Similarly, exactly there are 5 heads. Right? So what this means, when you flip a coin 5 times, what is the probability that you have exactly 5 heads? So the answer is again 1 by 32. So what is the observation you can make here? The observation I can make here, Mani, is I can see that this 0 and 5 is generally equal, and this bar and this bar seems equal in the y-axis value. So the value here is generally equal. So this is also equal to 31.25. What is the observation here? The observation here is this particular graph over here. So this particular graph over here is symmetrical. So symmetrical meaning this has some relationship with the normal distribution. Okay, so that is the observation that you can have. So let's say if this is, let's say 6 coin tosses. Okay, let's say if this is 6, let's say if we take 7, right? So how will the graph look like? So let's say when you flip a coin 7 times, what is the probability that you have 0 heads, 1 head, 2 heads, 3 heads, 4 heads, right? Something like that, right? What it means is no matter what your n is 6 or 7 or 8 or 9 or whatever, this particular graph, whenever you plot this probabilities of individual number of heads, always it will come in this particular shape. So either if it is like this, or either it is, let's say, the observation here is, Mani, this will be symmetrical. Like this bar will be same as this bar. This bar will be same as, the value of this bar will be same as this bar. Is it clear now?
Yes, it's clear now.
So all of these things will connect back in normal distribution. So that's the connection that I'm trying to draw here. Okay. No matter this 5, right? You could be 5 or 15 or 200 also, right? Doesn't matter. Always it will become like this. So it will come like this and so your bars will be smaller now. Like this. Any questions, guys? Any confusion or any doubts? So I'll upload these PPTs. So this one and the previous one. If you get a chance, please go through it. I think that will actually clear so many things. Once you listen once and then read the slides one more time, you guys will get more doubts, more explanation or more clarity. So if you get like at least 30 minutes or 45 minutes, I would request you guys to go through the slides so that you guys get more and more confidence on this probability. It is generally very confusing actually. Like if you do not understand the sentence that is given there, it's very difficult to come up with an answer. And probability has some relationship with machine learning. So that is the reason we are learning probability in statistics and machine learning. So there is good amount of probability used in machine learning. Okay. So with that, I think I'll close the class today a little bit earlier.
Yeah, Mani, can you share the link for practicing?
Yeah, I need to search for that actually. I need to look for my drive and I'll share with you guys practicing probability. Can you ping me the URL where you upload the PPT? So it is in your WhatsApp group, Sankarlal. If you click on your WhatsApp group, there is a Google Classroom e-link, and if you click on that, I think it will ask for your login, and you can log in there. Okay.
Yeah, I mean, in the classroom, I couldn't find it.
Okay. Classroom, you couldn't
In the
find.
Google Drive also, I'm not able to.
No, they asked me to upload in the class.
Is the issue with only for me or what about others? Everybody is able to see this?
Yeah, I was able to see in the classroom.
It's available.
It's available in Classroom. Classroom is Google's another product you can search.
Yeah, that I got it.
And the code is present in group description.
Yeah, I
How
got
to
it from
enter.
there only, but
Maybe you have to ask.
yeah, I will connect with Abhishek.
You ask for permission, I think.
Yeah, permission. Yeah. Thanks, man.
Any other questions or doubts?
Nothing. Thank you, Mani.
So I hope you guys got some basic idea, like conditional probability based theorem. I know it is a little bit confusing. So I'll upload the slides. There is one problem. I want you guys to practice that. And I'll share the URL where you can practice more on probability. So keep practicing, guys. If you don't practice, then it will be very, very difficult, because after 1 week, you will forget everything. So probability is like that, like very, very confusing. So keep practicing so that you guys will get more and more confidence. Okay. So if you guys don't, if you guys don't have any questions, then I'll close the class today.
Thank you.
Okay. Okay, guys. Bye bye. I'll close the class.
Thanks. Bye.